Okay, for today, we're reviewing yesterday's stuff. So let's see if you remember if I give you a function. First of all, don't say it out loud, but think to yourself, what kind of function is that Mr. Server just put up on the board? First of all, there's a word that starts with an R that's like the title of the whole unit. Do you know what that is? Rational. It's a rational function. All right. The parent of them all, the big mama, is the mother function. Kind of sounds bad if I say that, doesn't it? The parent function. How about that? The parent function of all of them is this: y equals 1 over x. Do you remember what that looks like? Sketch it. Sketch y equals 1 over x, because it's like the beginning of all of these. How many of you remembered that it was that one? Okay. Now, if that's 1 over x, then all of these are just kind of like little modifications, but you get some crazy differences when you start putting an extra x or two on top. All right. Somebody said this is a bot. What does that mean? Bigger on top. There's 3 kinds. There's bigger on top. What else is there? Bigger on bottom, and same on both. And do you know what the different asymptotes are for those? Those are horizontal asymptotes. This whole thing is category of horizontal asymptotes. I'm going to give you a bob, sob, and a bot, and I want you to tell me what the asymptote is. Here's a bob. Where's the asymptote? You should know. Don't say it. Write it. Here's a bot. And here is a sub. And you might think it's not a sub, but it is. Please figure out what the asymptotes are here, here, and here. Pause for a second while you try to remember the rules for horizontal asymptotes. I'm going to add one more thing, and that's I want you to also tell me what the vertical asymptote is. There can be multiple. I'll make these the red question marks. What are the vertical asymptotes for each of those 3 functions? Remember, the verticals have to do with the denominator being 0. And the horizontals have to follow those rules about ratios, about sometimes there aren't any horizontals. Sometimes it's whatever's on the outside. Okay, so let's see if you remember the horizontal asymptotes and the vertical asymptotes. So we're going to start reading answers on the horizontal, on the bigger on the bottom. Nico, what was your rationale on the bigger on the bottom kind?
0.
Just automatically the answer is going to be 0?
Not automatically, but in this case it's kind of obvious.
Okay, so why is it 0? And is it x equals 0 or y equals 0?
It is y equals 0.
Y equals 0, the horizontal asymptote. Okay, so their y equals 0. And why is it 0?
Because
Can't just say it's obvious. Why?
there's 0 outside.
It's what's outside of the fraction. That's your asymptote. Y equals 0. Because if there had been an 8 here, then they would have moved it up 8, and then your asymptote wouldn't have been at 0 anymore. It would have been at 8. So you're right. It's whatever's outside. Okay. Let's go with Nick V. Can you tell me the bigger on top rule?
There are none.
Yes. I'm going to put NA. Could have said NO for no answers. Okay. There's no, if it's bigger on top, there just aren't any horizontals. All right. Let's go with Owen on the horizontals for the same on both kind.
This should be 2 over 1. I think it's 2 over 1.
That's it. I'm just going to call it 2, even though it is 2 over 1. You are correct, because it's the ratio of the lead coefficients, and the lead coefficients were 2, and there is no number there, so I can just call it a 1. All right, good. Now the verticals. Let's go with Leah. What did you say the vertical for this top one was? X equals 0, you are correct, and you chose X equals because it's the vertical asymptotes. All right, and let's go with Miss. I don't know how to say it. AU. How do you say it? Thank you. All right, would you please do the bot? Oh, that's too easy, so we'll just say none. And then how about the basab, Naomi? And say your full name to me. Okay, I just didn't know if I should say the, how to say the U in there. Okay, good. All right, so Y equals, oh, sorry. Naomi, say it one more time. X equals, and Y. Can you tell me that? It makes the bottom 0, as I think what I heard. I have this really loud fan right behind me, and it echoes off of these, so, and your voice is kind of quiet, so if I misinterpreted you, I apologize. Yes?
How come the vertical asymptote for the bot one isn't just 0?
It is, you need to do more, right?
Dang.
Isn't there a
Yep.
difference
Yeah, I
between
thought it was zero.
9 and 0?
There is a difference, and I should say, you are right, I should say 0, and I get what you mean by, I just didn't want to, like, 0 is nothing, but X equals 0 is a thing, so I should have put that. I apologize. I was too, yeah, I had a hard time hearing in the back row, so I just kind of guessed what she said, but okay. Back to, we've now got our answers, and where did all these verticals come from? I want to focus in on that for a second. Where all these verticals came from was what made the bottom 0. It's the things that made the bottom 0. Where did I get the horizontals from? Much more complicated rules. The horizontals all came from these rules. Bigger on bottom, bigger on top, same on both. They all have rules for them. The bigger on the bottom kind is whatever's on the outside. The bot kind is there just isn't any. And the same on both kind is a ratio of the lead coefficients. All right, cool. Now, how do you get other points? So like, let's say I was talking about, let's say here's an equation. I'm going to give you an equation. It's not just a random equation, but it's an equation where I'm not going to know a lot of the points. I'll have to make up a ton of points for this one because it's going to be a strange looking thing. It's going to do that cross the asymptote deal. And so the hard part here is not finding the asymptotes. That's easy. It's finding the other points that aren't on those asymptotes. All right, so in the denominator, you're going to have an x minus 3, and then we're going to square it. And on the top, we're going to have a 2x squared. Now, I said that it's super easy to find the asymptotes, but let's just make sure you can. Figure out the horizontal asymptotes, if any, and figure out the vertical asymptotes, if any. Sophia, can you tell me the horizontals? Is this a bob, sob, or a bot? It's a sob. What's the rule for same on both? Ratio of the what's? The lead coefficients on the top and the bottom, yes. So what do you get? Y equals 2 is correct. The verticals. Michelle. X equals what? Regular 3, because it makes the bottom 0. Okay. Now, did anybody even look to see if these would have factored? I'm glad you looked, because that would matter. Because do you get if it would have factored, there would have been a hole? And if you could have factored something out of the top and the bottom, let's say there was an x on the top and an x on the bottom that could factor, then there would have been a hole at 0. So we got to look for those. There wasn't this time, but at least look for it. Okay, so now the harder part, find me points. I'm going to give you a whole bunch of numbers to put in because this is how you do it in the real world. You know there's asymptotes at 2 and 3, so everybody make a quick sketch of that. Y equals 2, there's a dotted line going across here. And x equals 3 is a dotted line going down here at 3 and 2. So then I need x values that basically go across here. See all of those hash marks I just put there? I need a dot in all of those places. So I'm going to put in x equals -2, -1, 0, 1, 2, 3, 4, and 5. I need you to find points in all of those places because this is a weird curvy line. So let's just find one of them first. We're going to all find -2. Okay, so everybody put in -2 right now into this equation. Be ready to be called upon. I'm going to either pick somebody I feel like is not paying attention or somebody who hasn't been moving their hands in a while. Or I'll use the dice of destiny to just pick random person. So just make sure we're putting in these numbers right. If you put in -2, I'll choose dice of destiny this time. Sophia wants to hear from you again. What'd you get on the top when you put in the -2 here? 8 over what's on the bottom? 8 over 25? Now, since this is just a sketch, do you get that I can say that's about 1/3? Do you get how 8 times 3 is 24 and it's pretty close to 1/3? Okay, so you could do that same thing. You could just say that's about 1/3. And if you want to know what about is, it's a squiggly equals. Squiggly equals means about 1/3. I'm just trying to say, I know it's not 1/3, but is close. So -2 comma 1/3. -2 comma 1/3, that doesn't go up very far. I'm going to put it about there. That's the first of many important points. Now I'm going to actually change colors because my red dots were my asymptotes, so I'm going to choose blue dots. All right, and we'll get a bunch of blue dots. Now be ready to be called on so I can get the rest of these points. -2 was 1/3. Owen, would you tell me what -1 was? I'll call in you in a moment. You're in charge of that one. Lillian, do you have any of these? Okay, Lillian, I'm giving you 0. Figure out 0. Drew Malk, you're in charge of 1. 2 is going to be Naomi. 3 is going to be Saloni. 4 is going to be a random person, so everybody do 4. And 5. The last 2 will be randos. Okay. Got -1? -1/8. I can verify that one for you. Okay, would you agree 1/8 is smaller than 1/3? So when we graph this, we just have to be careful with that. -1 was 1/8, which is even smaller than 1/3, so it's a little lower. Okay. Lillian, which one were you doing?
0.
What'd you get?
I got just like 0.
You are correct. 0, 0 is a point on this graph. Right there. Man, that's really hard to make it see. I'm going to make it red to make it pop. Okay. Nico, you're one of my random people I'm choosing for number 4. What'd you get for 4?
32.
You are correct. It's a really big number anyways. And let's go back to 1. Who had 1? Drew.
2/4 or 1/2.
1 and 1/2. Okay, good. Yep, I agree. 1 goes with 1/2.
Oh.
Is that what you meant?
Yeah.
Good. All right. And then who had 2? Please, Naomi.
8.
I agree. And Leah, can you tell? Oh, wait, no, somebody. Who had 3?
I got 0.
Solani? 0? I don't think so, but I could be wrong. Can anybody verify what 3 is? Oh, wait a minute. X equals 3 was weird. Look. X equals 3 is on the asymptote line. So it actually shouldn't have come out with 0. It's the asymptote. So if we put in 3, we really should get something that doesn't exist. Do you get how on the bottom we're going to have a 0? And you divide by 0 so that it doesn't exist. Okay. All right. And so I'm going to graph a few more points here. 1 was 1/2. And this did get weird. Do you get it was going down? I totally thought it was going to keep going down. But then it started to go back up again. And at 2, it becomes 8. Over 2 up 8 is like way up there. It's almost like it went through the asymptote. And I'm going to show you exactly where it did. Everybody, this is the most important one. Put in 1.5, aka 1.5. And I know it's a little bit of a pain, but it works out super nice. When you put in 1.5 into the function, right here and here, 1.5. See what you get. Do you get that the 1.5 squareds on the top and the bottom cancel? Do you get that? 1.5 squared is here, and then down here you have 1.5 squared again. Because when you square it, the negative will be gone anyway, right? So, do you get that those cancel and then the answer comes out to be 2? Now, what's really weird about that? It's on the asymptote. At 1.5, it hits the asymptote and goes right through it. And I warned you that now that you're old enough to handle it, we aren't just saying that asymptotes are something you get closer and closer to. They sometimes go through them. All right, so I'm going to make my line here. I can tell that's just going to keep going up super steep. And then this one, I know how asymptotic behavior goes. It's eventually just going to get closer and closer to that asymptote there. So I just kind of free-handed that, and I'd be okay with that. Now the point 4 was 4 comma 32. That's again super way, way, way up there. And 5 is, wait a minute, no, 5 starts getting smaller again. All right, I'm going to call on a random person for 5. That's row 4. Last person, Herbst. 25 over 2. Can you simplify that for me? What's half of 25? 12.5. Can anybody verify 12.5? Okay, good. So 5 comma 12.5. Well, it's coming down. It was at 32. And now it's down to 12.5, which is like half of that. And I'm going to continue this graph with red here and go. It goes like that. So that was one weird graph. It went through the asymptote. Then, of course, it gets closer and closer. Here, it gets closer and closer. Here, it gets closer and closer to the asymptote. And there, it'll get closer and closer to that asymptote. The bigger the numbers you put in, like 6, 7, 8, 9, they just keep getting closer and closer to 3. Yes?
So is there a reason why there are certain fractions and stuff like that that make this happen?
That is an excellent question.
Is there like a sign where we'd be like, oh, this fraction has this?
Yeah, I get what
so-
you're saying, and I wish I had that answer. I can't tell you that I have figured out the magic recipe for making it go through the asymptote.
So
It kind of just happens out of
sometimes
nowhere.
it will.
Yup, I know, it's weird. You just have to, when you get close to the asymptote, you got to just go, well, let me see if this is one of the kinds that goes through it. We did have one on homework last night. I think it was number 7. Did anybody verify that there was one that went through the asymptote on the homework last night? Pretty sure it was number 7. All right. So, if some of you are like, oh crap, I hope he isn't collecting that homework. I am, but not right this second. Because we're spending another day on that homework from last night. So if you didn't get them all done, you'll have a chance to work on that more later this hour. All right. Okay, so moral of the story.
Yeah, go
Sometimes the hard part, the big picture here, is you find the asymptotes. That's supposed to be the easy part. Okay? Then you find a whole bunch of points, and when you get near the asymptote, like here, I was thinking it wasn't going to go up and through the asymptote. I was thinking it was going to go down and go that way, but it didn't. And you don't know until you keep on finding more points. And then we found this one where it went right on the asymptote. And that was the real, like, okay, now I know it's not going to turn around and go down. It's going through the asymptote. And then the other numbers were really big as they got closer and closer to that asymptote. And it kept going up. All right, so more than ever, you've got to be able to find points. That's why it's on the top 20. It's one of the top 20 most important things, being able to find points on functions. Okay, and man, those must seem like super easy functions now. All right, so what's your homework? Well, it's going to be to practice. Like I showed you how to box earlier in 1 minute. Well, you wouldn't be a good boxer until you've done a few bouts with people. Okay, so now you're going to be actually, going to battle with these functions. And yesterday I gave you the assignment and I said, cut off this, this, and this. This time, your assignment is to finish the ones that we skipped, except the ones that say challenger, because those are just brutal. So there are some that are labeled challenger problems. Those are just beyond what you have to know how to do for this class. If you'd like the challenge, go for it. But do all the problems that weren't assigned yesterday. So for some of you that didn't do much on your homework for last night, you got an extra chance, and now we spent 2 nights on it. You can bet that we're going to do something to grade that one, so get it done. And that is all I have for it. For the new stuff for today, I am grading the lab, so anybody that missed today, you're going to be having to talk to me about getting your lab graded. I'll be grading the ones for people that are absent today, so talk to me about that later.